Hello everyone and welcome to Grand Theft Physics 220, Week 7, Lab 7. This week we're going to look at the wave characteristics analysis of two periodic cosines. One will be red, one will be blue. And the simulations can be downloaded from the Grathms website and the lab lessons link under with the file name, the physics simulations. This week the experiment is 7B. So we see here we want to open the 7B, and that'll open the interactive physics. And now we can start to examine this and see what it looks like. Okay, so again, as all these, I will just kind of let these run. We can see what this looks like. And notice you get two cosine waves with differing amplitudes, periods, and frequencies. And now what we're going to do is you guys are going to examine this to determine all of those properties. So if we look at the answer sheet here, basically we want to determine the amplitude, period, frequency, wavelength, and velocity. What we want to remember is there are some relationships here. Specifically, period is 1 over the frequency, and we can measure either of those directly and calculate the other one. And also, once we have the wavelength here, remember the velocity is the wavelength times the frequency. So you're going to be able to calculate those knowing those values and using those. So let's go back over to the actual experiment. So of course it's kind of run through its cycle. We want to reset that. You can always hit reset at any one point. This just has the property here. You notice it will run over itself. One way you can always do is you can always close it out. Go to File, and it's usually under the first one, the one you just did. You can see some of the other ones we worked on in the past also. And now we can open that. So we can step this through piece by piece. And notice one of the things is the time for each wave. The time is time for both of them. You can watch how the waves progress. Okay, you notice the blue one's starting to come back up. The red one is still going through a cycle. And remember, what defines a period with a wave is the amount of time for it to go through one complete cycle. Okay, so as we see here, the blue wave is just starting to come through its cycle. Okay, and again, it's a little easy sometimes to just move it through that way. So you want to move it just to the point where the blue's coming through the complete cycle. And then you can get the period from that. So you would come over here, fill out the value for the period that you were concerned with, and let's just say for argument's sake it was 0.25 seconds. Okay, then we know the frequency is 1 over that, so this is going to be 4. Remember, our units for frequency are hertz, or inverse seconds. Of course, that's not really what's going on there, but I'm just using that as an example. Okay. Now you could step it through also, if we kept going, and get the same thing eventually for the red ball also. Okay, and that's going to be pretty close to where that is. And you would do the same type of calculation here. Now, another thing you may notice is it gives the X and Y position of the red ball, and then the same thing down here for the blue ball. The X position runs this way, the Y position runs this way. This is going to be helpful because this is going to help us determine the amplitude and the wavelength. And you're going to want to look at this and think about it for a second and realize which one is which. So, seeing how the waves are actually drawn, we notice that the Y position is going to correspond to the amplitude, and the X position is going to correspond to the wavelength. And again, we're going to use the same criteria we did before for the wavelength, that being a complete wave cycle. So now that we realize that the amplitude is the y and the wavelength is the x, notice we're going to have to, let's reset this, run it again. And remember, you can always do that. If you get the settings kind of messed up, you can always close it. If it asks you to save any of the changes, click no, because then all the initial values are changed and you have to work through it. So you're going to watch this move through, and that would give us our one wavelength for the blue ball, and we could determine its x position. Now again, I'm looking at the values, it's not that value we had there isn't the x position, it's the difference between where you start and where you actually end, and you can notice the position of the ball there. So it's going to be 2.419 minus -1, so you can see the actual value there. Now the amplitude, is going to be given by the y position. So I always kind of take it and make it go. And notice the y for the red ball starting at 0. For the blue ball, it's also starting relatively at 0. So you got to let it move through. You back it up a little bit for the blue. You could determine the amplitude there. And then you let it run through and see how this, you can always, if it gets a little off, just reset it. So there's the blue there. You can keep it going, determine the red. Notice the blue is almost done for a period. And then you would just let it move through a few. And finally, by doing this, then you can go back over. Sorry, I lost my little worksheet here. And finally, you can go back and calculate the wavelength and frequency. And remember, if you keep it in meters for the wavelength and inverse seconds for the frequency, that will give you meters per second. Well, that should give you enough information to be able to work on the lab. And remember, at any times you have any questions, please contact your instructor.